Hello, welcome everyone. Welcome if you're just joining. Hiya, hopefully you can all hear me okay. Feel free to say hello in the chat. We're going to be looking at a nice A-level topic today that kind of crosses over between pure maths and a little bit of mechanics as well, and some of the applied maths. We're going to be looking at parabolas and how they're used in the A-level for modelling. So welcome if you're here already. Feel free to say hi. Feel free to ask questions as we go, and also comment and share answers as well as we work through problems. So welcome everyone. Lovely to see people joining already. Well done for joining on a Sunday, especially as kind of the year's ticking on already and we're kind of fully into this first term of school. So welcome. Hello. Hi guys. Excellent. Thanks for joining so promptly as well. Feel free to say hello in the chat. I'll keep that open so I can see your questions, your answers and stuff as we go forward today with this topic. So we're going to be looking at parabolas, which are kind of essentially the shapes of quadratic graphs. So it's an idea that we're actually hopefully quite familiar with, but we're going to see it in a context. So this is really useful and actually comes up all over the place across the Maths A level. And we're going to get started shortly. So it'd be great to see people join. Feel free to say hello. I'm going to get started shortly. I just want to give everyone a minute or two to log in. Obviously, welcome if you're just joining now. Great to see so many of you joining so quickly. So as I said, we're going to be looking at parabolas and how they come up in A-level questions. Do feel free to say hi if you haven't already. I'm going to share the screen and we'll get started. So here we go. Hopefully you guys can see this. Hi, welcome guys. Feel free to say hi if you haven't already. We're going to be looking at modelling with parabolas today. So mathematical modelling is a really important part of the A-level, particularly the new A-level that's in place now, and actually so it should be really. I think mathematical modelling is really important in general, that we understand that and we're able to model things mathematically. Good, parabolas. Yes, lovely. Brilliant. So that's what we're going to be looking at. And actually the calculator skills are really important as well within this topic. So the use of ICT and understanding how to use the scientific calculators to sort of shortcut things and also help sense check these techniques in an exam pressured situation. So hopefully you can all see my slides now. We're about to start with this web class. Welcome, as I said, if you've just joined. Hi, and thanks for messaging those that already have. We're going to get cracking and look at modelling with parabolas. So I'm Max, I'm head of maths at Snap Revise, and I did a maths degree not too long ago, but I've been teaching maths ever since. So A-level, GCSE and Key Stage 3 as well for the last sort of 4 or 5 years. And I've seen the A-level change to the newer A-level and how the kind of content has been repackaged and stuff. So it's been a really interesting time to be teaching the A-level maths, having done it previously myself, gone to university and done a maths degree, and then seen the A-level that I did come in and then also change as well. So we'll talk about resources and Snap Revise as well later, but it'd be great. So this lesson should be, most of the content should be sort of 45 minutes or so, maybe 50 minutes. And then I'll talk about Snap Revise, answer any questions as well at the end. So best part of an hour. But as I said, we're going to be cracking on with modelling with parabolas, which are a big important part of the A-level maths. So good question. What exam board is this for? This should be applicable to all of them. This is something that's part of the syllabus for all and specification for all exam boards. So just a quick mention of this kind of back to school offer. We've got a discount code. If you're interested in what we do and you're interested in some of the courses that we run on the Snap Revise platform, I'll talk about this code later. It expires in 48 hours. And it gives you 25% off the Snap Revise platform and package for the courses that we offer. So I'll show you the website towards the end and talk about that if it's something you're interested in and would help with your revision and your work towards your A-level. So I'll come back to that. But what we're going to do, we're going to crack on and look at this topic as a whole now. We're going to be looking at the key features of parabolic functions and the graphs, also understanding what they could represent in the context of a mathematical model, which in terms of exam questions is really actually important and something that you need to be really confident with. And then we'll look at exam questions actually on this topic and how to approach them. So you'll also notice there that it said I won't be deriving equations for projectile motion, but the point of that is that this does kind of bridge and straddle between applied maths and pure, and it does come up in the mechanics part of the course as well. So it's a really good skill to be confident with. Right, let's get started. So just things we should already be familiar with in terms of quadratics is hopefully things like factorizing a quadratic we can kind of do. I'm just going to write these in. So for example, factorize if the quadratic factorizes. So for example, I think this one does, we're going to get 4 plus x and then 3 minus 2x. You could also use the quadratic formula to solve it. And some of you with some of the calculators that are now allowed in the exams can literally type in the quadratic into the calculator and it solves it for you. You don't even need to use the quadratic formula for some of these calculators. So hopefully you guys are aware of that as well. That's really handy. But if not, you might recognize the quadratic formula from GCSE or previous studies of maths. So hopefully this is a little reminder, quadratic formula, which you could use. And for this scenario, that would give you 5 plus or minus the square root, 5 squared minus 4 times minus 2 times 12, all over 2 times minus 2, and your answers would come out. The other thing we also need to be confident with, and I remember when I was doing my A-levels, people didn't like this skill and they tried to avoid learning it, completing the square. And actually, if you dodge learning this and you think, I'm not going to learn completing the square, I don't like it, I've got a calculator that solves it. This isn't just useful for solving. Completing the square allows us to find turning points and is actually useful in other topics as well, which some of you might have seen for things like circles. It's a really important skill that's kind of multifaceted in terms of its applications. So yeah, that's a kind of important point. The other thing is that we'll also notice, those that have started the A-level, being able to sketch graphs is really important, knowing that a negative parabola will have this sort of unhappy face shape, and it will have a turning point that will be a maximum point of the graph. We know that the y-intercept will be 12. We know that the solutions will be the x-intercepts, which would actually come out as -4. And the positive one from this factor here would be 3/2 or 1.5. And the turning point from completing the square would be 5/4, 121/8. Now, that's a lot of information in that first slide of what do we already know, but we're going to break this down and we're going to kind of use this going forward. If you're kind of familiar with the calculators as well and you know how to get turning points on some of them, that can be really handy. But being able to sketch a graph is a really key underlying skill for this topic. So there might be a few bits there that you feel a little bit like you need to work on. I would really advise that everything within this topic you are making sure you attack head on and you really are proactive with, because stuff will grow in difficulty if you don't attack them head on. So as I said, someone asked earlier, what exam board is this for? This is applicable for AQA, OCR, Edexcel. All of the A-levels had a big overhaul in 2017, and the syllabus was really defined carefully that all boards need to be covering kind of the same main key topics. And this absolutely is one of them. So quadratics and mathematical modeling is a really important part of all of the A-levels, whatever exam board you're with. So this is a really good thing to be going through today. So just looking at this first graph here, y equals 30x minus 10 minus 5x squared. And interpreting what the different bits of the graph are. Oh, okay, brilliant question. Yeah, lovely points, guys. Yeah, absolutely. In terms of, so some of the calculators, for example, I think the Casio class quiz, you can type polynomials and cubics and quartics in, and if you press equals, it gives you the roots, and if you keep pressing equals, it gives you the turning points, and that's in the polynomial function. And some of the other newer calculators do that as well. It's under a sort of a section of the menu called polynomial, and then you say degree 2, and it will let you type the quadratic in. Yes, it does do it on there, absolutely. Hannah, yeah, brilliant. So look that up. I think it's menu alpha A, and then the polynomial degree 2, and then you can go through from there and you just keep clicking equals and it gives you turning points. Brilliant. Well done, guys. Yeah, so good. Some of you have mentioned what's going on here. Here we have a stationary point. It's a maximum. So if we're asked to interpret a graph, we're not asked to draw it. At this point, we know that the function is at some sort of maximum value of y, a maximum output. And it is really good to talk this through, because sometimes when it's a wordy question, we don't make the distinction with the graph unless we're presented with it. So that's the maximum of y. These values here, sometimes called the roots, but these values correspond to basically the solution of the quadratic. So the roots, the bits we would call the roots, depending on what the context is, x corresponds to basically when y equals 0, corresponds to y being equal to 0. What are the inputs that make that happen? And sometimes if this is to do with time, this y-intercept could be some sort of initial value or starting value. So maybe in a mechanics context, that's what we would see. So an initial value of y. The y-intercept is often really important in mathematical models because it's often a reference to the start. And then also if we were asked to solve something like this, where we want to find this value and this value, it's probably a skill you've done at GCSE, solving simultaneous equations graphically. But what this actually is doing in terms of a wordy question is finding values of x for a given y value. So what value of x spits out this y value? So value of x for a given y value. And it's just interpreting that. So if we take this a step further now, brilliant comments in the chat as well, guys. Thanks very much. If this now was dressed up as a context that involved perhaps temperature of water and lowercase t represented the time passed, this now has a bit more meaning than it did a minute ago. So what we've got is if we imagine capital T is the temperature, temperature of water, and it's following this parabolic model, temperature of water, and then lowercase t is talking about time passed, so the time that's elapsed while this model is being looked at. Then what we would have is we could kind of look at the specific bits and look at what's going on here. What can you guys tell me? What sort of things can we interpret from this? Well, what would this sort of tell us here, given that the value is -10 at this time? It would tell us that the initial temperature at time 0, basically initial temperature is -10. Does that make sense to everyone? Can we kind of see how that could relate to the model? Yeah, exactly. Well done. Excellent, Hannah. So that's talking about the starting temperature being -10. Well done. Now, if we were to see what does, yeah, excellent, superb responses, guys. So here and here, these are interesting points because these are when the temperature is 0 degrees. So this is basically the boundaries of the times when the water is actually frozen, if 0 is where it's freezing. So these are the times when the water is freezing or on that brink of going from freezing, like changing states, times when water is frozen. Ooh, the pen's gone a bit funny here. Pen went a bit frozen. Water is frozen. Lovely. And then what else we've got, if we look at this, what would this correspond to in terms of like a contextual description of this point here? What could we say that that sort of represents? Brilliant, superb. At 3 hours, lovely, at 3 hours, we know that the temperature is at its maximum of 35 degrees. So at 3 hours, temperature is at, so you've actually got 2 bits of information there. Temperature at maximum, which we actually also know is 35 degrees. Lovely. And then also if we were asked to solve something like this would be like at what times is the temperature 30? Okay. Brilliant, superb. And we could go between 2 hours and 4 hours. The temperature is above 30 degrees. Okay, so there's lots you could do with this question, but it's kind of straight off the back of a normal, what we would see in pure maths, quadratic graph presented to us, now dressed up with a bit of a context. So we're going to move on. I'm going to take this a bit further and look at some exam style questions. Can you just give me a little indication in the chat of how confident you feel with that sort of setup? A 1 for really quite happy, 2 if it's kind of okay, and then 3 if you're super confused, which I hope isn't the case. And looking at the chat, it doesn't appear to be, but please do indicate to me any questions. Please stop me as we go and ask, but just give me a quick indication of how you're finding that first bit. Yeah, brilliant. And I'm really appreciative of the comments and the questions as we've gone along, guys. Please do more of that as we go. So yeah, lovely. You can use the emojis as well. Thank you. Excellent. Okay, so hopefully we're okay with it, but let's see it now in an exam context and see how we feel. So here's a lovely, thanks guys. Okay, so a publisher, now again, lots of words. It looks like an exam style question. Let's not let it put us off. And let's go through this carefully. So a publisher has to choose the price at which to sell a certain new book. The total profit T that the publisher will make depends on the price P. He decides to use a model that includes the 2 following assumptions. If the price is low, many copies will be sold, but the profit on each copy will be small. So the total profit will be small. But if the price is high, the profit will be high, but few copies will be sold, so the profit will be small. And if you think about it, if a book is overpriced, okay, when you sell them, it will make a lot of money, but you won't sell many. So overall, it's probably not going to be great to overprice it. So there's 2 kind of things going on. And the graph below shows 2 possible models. Explain how model A is inconsistent with one of the assumptions given above. So look at the 2 assumptions and think, why would model A not work? Because perhaps it works for one of them. What's problem? What is the problem with the model A? So model A here shows this sort of relationship between price and time. Can anyone see any obvious problems that break one of these assumptions? So let's look at what's happening as P gets bigger and bigger. Well, hopefully we see when P is large, so is T, which breaks the second assumption. Does that make sense to everyone? So it kind of covers the first assumption, but it doesn't really make sense for the second one. Yes, so excellent, superb. So which breaks is the second assumption that's the problem. So well done if you picked up on that. It doesn't actually work for the second thing that the question said. Brilliant, really good. And well done for referencing it as like a linear model assumption. Yeah, absolutely. Then that was really good. So then for part B, it says, given that the equation of the curve in model B is quadratic, show that this equation is of the form that given there and find the value of K. So what do we know? Because this is maybe getting a little bit more classically mathsy. We're now being told, well, what's the equation of it? What is this actually showing? So it's a quadratic, it's parabolic, and we've got the turning point, and it's actually giving it to us in a kind of complete in the square way. And we also know 2 points that we would refer to as the roots. So is everyone happy that the roots that we have are 0 and 12? So we kind of know how it would factorize. So that's why it would be in the form something 12p minus p squared, because the factors will be 12 and also p will come out, and that would be the solution of 0. Good. So the other thing we can think of is we know a specific point it will go through. So we can plug that in as x and y or as p and t and work out the value of k. So if t is equal to, and so this hopefully makes it a little bit easier. Yeah, and p is equal to 6, we can use the format they've given us and then say, right, let's sub p and t in and find out k. So we'd get 7,200 is equal to k times 12 times 6 minus 6 squared and that will come out, apologies guys, I'm trying to make that a bit neater, and that will come out as 7,200 is equal to 36k, so k will equal to 200, and then we found the value of k. Is that all okay? Does that make sense? So I subbed that point in to the general form of the model to find the value of k. So you could kind of think of completing the square, but I think actually it's better to use the question to its advantage here. That was a really good question, because when I first saw this, I thought, oh, we kind of want to use completing the square. But actually, what we do also forget is we can see the roots. We can kind of see that it would factorize, and a p could come out, and a 12 could come out. And also it's a negative quadratic, so it will be a minus p squared graph. And use that to your advantage, because then, because they've kind of told you how they want the answer presented, you can just sub those two values in to find the only unknown, which is k. But I really like how you're thinking there, Hannah. That was a really good suggestion. Right, I'm going to move this on. So very well done. There's a couple of little follow-up questions. So it says, comment briefly on how realistic model B may be in the following cases. And again, this is almost bordering on like applied maths kind of style, where they ask you to comment little throwaway marks that are actually very specific in what they're looking for. So comment on how realistic model B might be in the following cases: when P is equal to 0 or P is equal to 12.1. So any suggestions? Because this isn't, I don't think this is necessarily obvious. And I don't think necessarily at the time I would have known immediately what they were talking about. So if P equals, well, this does feel very economics based, doesn't it? And I think hopefully for those that are studying economics as well, you will get that blend of with the maths, the overlap, which is great. But yeah, let's have a little think here. This is a really actually not too bad question once you've seen a few like this. So when P equals to 0, let's look what's happening. T would equal to 0. And T represents the profit. So if I kind of gave them away, if I kind of priced it at 0, can you guys see that this would actually not mean 0 profit, but instead the company would actually probably suffer a loss because of the cost of everything behind the sort of manufacturing. Oops, sorry about the pen there, guys. Company would have a loss due to sort of publishing costs, due to costs. So you kind of have to think of it in the context a little bit. And they might accept a few different answers, but I know this didn't always sit comfortably with me in maths, because I used to think, do they want me to think about this in the like wider context? And actually they do a little bit, but you haven't got to know the other subject or know everything about publishing. You've just got to kind of be able to put this in a context. Yeah, there is a loss from making all the books. Absolutely, anything along those lines will explain it quite nicely, that if this was modeling something in real life, you've got to actually take into account other factors. Absolutely. And then the other thing, when P is 12.1, what's the issue here? What's happening with this? What's this suggesting? So this could potentially be realistic, but what we're going to do is explain what actually it would suggest. Are we happy it would actually suggest that T is less than 0, meaning that there's a loss? That actually the profit is negative, meaning it's a loss. So at 12.1, T is negative. So this is potentially realistic, because it did say that after a certain amount, they would actually make a loss because they wouldn't sell many. And that's where this model actually wasn't good. So this is potentially realistic. We don't know what that amount is, but that's actually what's quite good about this model, is that it goes up and then back down, and then it would run you into a loss again. So this is potentially realistic if costs are greater than the revenue. Oops. Because remember, these graphs aren't looking at how many you sell. They're kind of looking at how much you're pitching the price at, are greater than the revenue. And you could phrase that in your own way, but it does tie in with that assumption too. much better than the first model did, because the first model didn't sort of account for that second assumption. Sorry about this sort of relatively funky writing. Hopefully it will improve. Okay, right, good. So what we're going to do now is we're going to carry on and look at interpreting parabolic equations in more of a kind of dressed up wordy sense. So the revenue a company will make from selling their line of bird feeders is equal to the product of their retail price, P, and the number of feeders sold. Research suggests that the company will sell 5,000 feeders if priced at £5, but will sell 400 less for every pound the price is above this. Derive an equation in R and P. Now, I used to absolutely hate questions like this because I felt like I had to read it about 5 times and then sense check it, and then you're not 100% confident, but we'll break this down and do this carefully together. So let's think about what else is going on here. So we've got the revenue R, the company will make from selling their line of bird feeders, is equal to the product of the retail price. So the retail price times by something, the number of feeders sold. They haven't given us a letter for that, but maybe we could introduce one. So let's let S be the number sold for now, because we don't really want to introduce another variable, but we can deal with that in a minute. So then hopefully we're happy that R is equal to P times S. Does everyone get that? Now, don't worry if you feel like this already is a bit nasty. We're going to break it down together and make sure everyone's really confident with it. But please do stop me, ask me to backtrack, rewind, or clarify anything here, because this setting it up can be a bit of a struggle sometimes. So let S be the number sold. R is equal to P times S. So it's equal to the product of the retail price times by the amount they sell will be the revenue they make. So that's what that said, that first bit. Then it says research suggests that the company will sell 5,000 feeders if priced at £5, but will sell 400 less for every pound above this, and then derive an equation in R and P. So this is where we've got to kind of work out how S fits into this and how we can kind of replace it. So what we know is that if P is equal to 0, no, hang on. We'll sell 400. Right. So if S actually is equal to 5,000, and it will be priced at £5, increasing P by 1 reduces S by 400. Does that make sense to everyone? So what we get is that S is like 5,000 minus 400p. Sorry, I'm going to rewrite that. That tells us that S is equal to 5,000 minus 400p. Okay, so I'll talk about at the end, I'll talk about the other web classes we do and what we have available on the Snap Revised website in terms of all the previous web classes of all the whole A level that we've covered, and what we've got coming up as well. Absolutely. Right. So what that means is we know at 5,000 P0 is an option. Then what this actually factorizes is R is equal to P times 5,000 minus 400p. Because what I'm doing is I'm replacing S with this. So the relationship of S is the amount that you sell, is that it will basically be 5,000, but every amount you increase by £1, you sell 400 less. So that's how S is working. The number sold is based on this relationship, and that will be times by P. So we get this kind of quadratic setup, which would be P times 5,000 minus 400p. Sorry, I'll have a little look at the other questions towards the end because I do want to try and answer those, but I'll carry on with this. And so apologies if I've missed anything, but I'll try and answer the ones to do with this first. But yeah, really good questions and comments coming in. Right, any questions about this that needs clarified? Because I think this is, I think, quite hard to interpret when you first see it. But actually, we know it's a product of P times S. Even though they've not given us S, we know it's times something. And we need to define that something in terms of P. And then you've got this product of P times something to do with P, which effectively forms a quadratic. So where we go with that, you could expand it out and you'd get this, is that we then have the model and it says determine the range of prices which will result in the revenue greater than 10,000. So what we've got is we've actually got a quadratic inequality, which again, a lot of the calculators now do. So if you're looking at old A-level papers and old A-level practice, you might see that some of the quadratic inequalities are worth a lot of marks, and nowadays they're worth a lot less. And that is because the calculators do sort of facilitate that. Could you not write it as, yeah, is that not the same? Yeah. Yeah, good question. Yeah, exactly. That's what we did. We expanded it and got that. Brilliant. Lovely. So then what we're going to do is get this all onto one side. Oops. Struggling to write here. Here we go. 5,000p minus 400p squared minus 10,000 greater than 0. As I said, your calculator's now solved that. You could divide this all through, simplify it to 25p minus 2p squared minus 50 greater than 0. This does actually factorize, and we would get it as 5 minus 2p, p minus 10 greater than 0. So what that will tell us is that p is between £10, £2.50. Kind of in there. That'd be the 10,000 mark. And the values that would correspond would be £2.50 and 10. Okay, so that's kind of how it would have worked for this one. But as I said, your calculators would be a huge advantage because instead of under the polynomial part, you could also now do inequalities as well. I think it might be on the same sort of menu, depending on the calculator, and they'll do quadratic inequalities for you. And that could be how the model comes up as well. It could be an inequality. Now, the next part of the question I think is good to look at, and then we'll look at some exam style ones, is the greatest value. So any ideas on what we could do here? And again, use of the calculator could be quite handy. But here, if we're trying to determine the greatest value, we could look to do completing the square. So the first thing I would do is I would take minus 400 out, and I would get p squared minus 12.5 or 25 over 2. I personally think it's really good to do completing the square using fractions, because although some people just don't like completing the square, it's a lot easier to square a fraction than square a decimal. So what we would get is minus 400, and then we would get p minus 25 over 4. If you divide that by 2 squared, minus 25 over 4 all squared, and then that would become minus 400 p minus 25 over 4 squared minus 625 over 16. Then if you times that by minus 400, we get minus 400. Brilliant. Yeah, lovely suggestion. You could also find turning points using differentiation for those that have done that skill. That's a superb suggestion. And there are other techniques, as I said, on the calculator as well. I'm going to just go over this one because this is a technique everyone should have hopefully covered. Either way, that value there is the maximum. So that is what we're hopefully finding, that the revenue maximum is 15,625 pence. So, oh no, it was in pounds, wasn't it? Yeah, of course it was. Sorry, 15,625 pounds. And the value of P that allows for that revenue is this value here, 25 over 4. So that's when P is £6.25. So to maximize your revenue, you'd price it at £6.25, and the maximum revenue you'd get as a result of that is £15,625. Oh, yeah, good. Sorry, yeah. So for those that haven't heard of differentiation, it's towards the end of the pure content of year 12, and you do it in year 13. And it actually then consolidates some of the stuff you do earlier on. But differentiation and calculus is very new at A-level. So don't panic, but it's nice to actually be mindful of that. So it's really lovely to see that going on in the discussion, because some people are obviously at different stages or covered things already, and it's kind of flagged up that there are going to be more techniques that you can do. And it's always actually nice to have a couple of options for what you could do for these topics. So very well done. Just another quick indication, guys, and then we're going to do some actual paper questions again, and then I'll talk about the other web classes we've got and try and answer any questions you guys have. So here we go. Just give me an indication, a 1, 2, or a 3. And then what we'll do is we'll look at kind of like a typical exam question that pulls all of this stuff together and see how we go. And I'll let you have a little think about it. So just a 1, 2, or a 3, just to kind of confirm how you guys have found this content, or how you're finding it, how confident you are. And then we'll look at some exam style questions for this. Cool. Lovely. Let me know. Right, let's have a little look. So here we go. So an archer shoots an arrow. Thank you guys for responding to that. Here's, again, an exam style question that we'll follow up with. An archer shoots an arrow. The height, h meters, of the arrow above the ground is modeled by this formula. H equals 1.8 plus 0.5 d minus 0.002 d squared, where d is the horizontal distance measured in meters. And that's of the arrow from the archer. Given that the arrow travels in a vertical plane until it hits the ground, find the horizontal distance traveled. So you can almost imagine how this will tie in with mechanics already. So if we want the horizontal distance, this is very mechanics based, actually, very like the projectile stuff you do. Is everyone happy that the horizontal distance is when h equals 0? So that's actually what they're telling us, is that the height above the ground is 0 when it gets to its horizontal distance, when it hits the ground, when it stops. Does that make sense? Because it's perhaps not straight away obvious. Yeah, so that's what we're looking for. So we're looking to solve which again is just solving a quadratic, which you can, t squared, which you can do. Okay, but again, as you go through the course and you do this in mechanics, that will become more obvious because you'll do a lot of scenarios like this. But at this stage, it's really good to just get a sense of the breadth of different ways it can come up, the different styles of question. So good. So that's what we're solving. We're effectively solving a quadratic. You could use a quadratic formula. If you're kind of good at using the calculator to find this, maybe an alternative way, feel free. And obviously, because it is A-level, chances are if they're trying to model something kind of like it would be in real life, the numbers aren't often particularly nice, but you still need to know, well, I just apply it all in the same way. Might take a couple of extra seconds, but I know what I'm doing, so you can work through it like that. Oh, okay, cool. That's great to hear. So the mechanics is very much applied. It's very kind of like physics in a lot of ways, but it does tie in with mathematical modeling from pure. So it's this sort of stuff. But yeah, quite a good course. For some people, it's quite a new topic. So this will come out as minus 4.40 meters. I think for some people, it does often feel a bit of a struggle to get started with the mechanics. But actually, as it goes, it does really help with this sort of skill, even in the pure maths. So yeah, hopefully that will be good for those starting that. So initial height of arrow is what this one's getting at. Of arrow. So for part B, with reference to the model, interpret the significance of the constant 1.8. Can we see that that's kind of like the y-intercept? So that effectively is your initial thing. Like we said before, the y-intercept is often the initial value. So the arrow was already 1.8 meters up when it was fired. So that's where it starts from, and then it ends at 0. But that's kind of what that's referring to, the y-intercept value. Cool, excellent. So what the next bit we're going to do is it says, given that the arrow travels in a vertical plane until it hits the ground, write this in this form. So it's effectively telling you to complete the square. It just isn't right. This is kind of between the two. This is accessible to year 12, this content, but could certainly come up in year 13 as well. The models can get a bit more complicated in year 13, but actually this could be in a final A-level paper, this sort of thing. So the model could involve, there could be trigonometric modeling, there could be exponential modeling, quadratic modeling, but this actual skill sees you through the whole A-level. So yeah, it's kind of a bit of a crossover one. It's a good topic to be looking at. So here we go. So H is equal to, now we want to do completing the square. So we're going to take out the bit that's making it complicated, and then we'll have d squared minus 200 to compensate for that factor taken out of the 0.4 minus 900, so that if you expanded this, it would still be this. And then we're going to complete the square on that. Oops. That would be d minus 100 squared minus Hello? Hello? Let me know if that's back on. I don't know if that's back. There was a bit of drama there. All the lights went off and it just went pitch black. Sorry, guys. Is that okay? Is that come back? I think that's pretty cool if it has, because that was a little bit of a strange one. But I think the drama might be over. We might be back on. Is that back? Can you guys hear me okay? Apologies, and hopefully that's now working. I'll reshare the screen because everything just went lights out for a minute, pitch black, and now we're here again, hopefully. Okay, cool. Apologies for that, guys. Thank you for sticking around, and sorry that it sort of cut out. Can you all see that? I've just reshared it. Hopefully that's visible again. Brilliant. Thanks, guys. We were getting right to the kind of end point of this, and I can't believe that happened. I think it was the enthusiasm for the maths just destroyed the whole. You might even be able to hear an alarm in the background. It's kind of big power cut where I am. So anyway, we're back. Let's carry on and get this one wrapped up. So very well done, and apologies again for that. Right, where are we? So we're just finishing this completing the square. And we're going to minus 900 off. So it wasn't the nicest one to do, but let's finish this question, expand it all out and tidy it up. Have you guys done trickier completing the squares like this before? Have we seen ones like this? So they're not the nicest to sort of look at, but the process is exactly the same. Okay, so hopefully we can see that. And those that have done the first few chapters of the pure book, the pure part of the course, will notice that this completing the square actually also ties in with graph transformations. That's why we're able to get maximums and minimums. Right, no worries. So these are the ones that probably need a bit of practice, but the process is exactly the same. So I'll talk about how you could perhaps approach this if you're not feeling potentially as confident with these harder ones, but this is a skill you don't want to sort of shy away from. So I'll just wrap this question up, and then I'll talk about Snap Revise and also some of the resources you can use to help you with your A-level. So part D, it says the maximum height of the arrow above the ground. Well, if you have it in the completing the square form, 22.1 minus 0.002 d minus 100 squared, this gives you the turning point. As I said, there's other techniques that you can use from the calculator, but this gives you the maximum here. So it's 22.1 meters. Now, if you did complete in the square and you got it wrong, but you referenced the correct bit of it in this, you would get like error carried forward marks. And then it says the horizontal distance when it's at a maximum, that refers to this bit. So that would be at 100 meters. Okay. So what I'm going to do is, because I think we've covered some big ideas there today, guys, and looked at some fairly complex and involved parabolic models, is I'm going to just talk about Snap Revise, some of the resources and some of the ways you can prepare for your A-level exams. Obviously, we've got these YouTube sessions, and I'm really appreciative for all the comments in the chat and the answers, and actually also with the disruption, how well you guys have carried on with this. But what I want to just talk about is that we've effectively looked at parabolic functions and graphs, what they refer to in the context of a model, like the temperature of the water being freezing, and then looked at actual exam style questions of this as well. The other thing I do just want to point out is, I mentioned it earlier, the models in year 13 and as you go through can become more complex and hopefully actually more realistic of whatever the scenario is showing. And the trigonometric modeling, where you're using things like the sine graph, the cos graph and so on, they are really important because it could model, say, for example, the temperature of a thermostat, the waves, it could be something kind of coastal related, but they are following this same process of what does the y-intercept mean? do I find the turning points? And as some of you have said, there's other techniques you can employ as you go through the course, things like differentiation. So it all does sort of converge and begin to overlap, but you do need the kind of stamina to see this course through and not let one bit put you off. So if there's a particular thing, if it's the completing the square or the graph work that you know you're struggling with, that might be something you want to work on. So what I wanted to just mention is, for those that have questions or want to follow up on this, as part of the Snap Revise package, there are web classes with drop-ins as well, where you can go through specific things, email them in, and we can kind of help you with that. Obviously, there's the YouTube courses as well, the YouTube sessions coming up. Yes, I think partial differentiation might be in further maths. I don't think single maths A level. Can you still hear me? Everyone still hear me okay? Can you all hear me? Yeah, so partial differentiation is, I think, in the further maths. I don't think it's in the single maths at all. Cool. What I'm going to do, I'm just going to stop sharing that there for a second, and I'm going to share with you now the Snap Revise website. So as I mentioned before, we've got a kind of discount here. Excellent, thanks, Adam. Where for 48 hours, we've got the code for the courses. And if you sign up for for example, the maths course, you'll get access to all these kind of brilliant resources that are tailored to the new A level. They're tailored bang on to the new A level. So they're not sort of out of date, what might have previously been on the A level. It's all packaged perfectly for the exam board for right now, with diagnostic quizzes that you can sort of work through, get a sense of your own understanding. Well, that was a good guess. I didn't even read the question. And you can sort of whiz through it, and it will work out what you know and don't know and break it down specifically to the course. And then the resources will be tailored for that for you. So you can work through the quizzes, then there'll be a follow-up on them. Then there's loads of revision resources. There's the web classes, but the whole A level has been broken down, the mechanics, the statistics, and the pure, tailored perfectly to the different exam boards. We also have web classes as part of this. So, for example, every Monday and Wednesday, we have year 12 sessions and year 13 sessions, followed by a drop-in where you can ask questions about any of them. So James will be doing the class tomorrow. There'll be classes tomorrow and a drop-in straight after. So you can email questions in and they'll be worked through. And then Wednesday, we've got sessions as well. And you can kind of see the whole schedule, but also you'll be able to backtrack and watch previous web classes that you might have missed. And the way we've designed the web classes are to generally follow what you'd cover in school at that sort of point in the year, but we've kind of completely covered the whole of pure mechanics and stats. And it's tailored, as I said, to bang on right up to date, the A levels that are in place now. The courses have so many really good, clear resources that you can follow along with for revision, kind of printable resources, and every part of the specification is broken down. So this is, oh, that's lovely to hear. Sorry, I'm just kind of half catching up with the chat as well. These sort of resources are really good for those working through the content and perhaps knowing where your weaknesses are. And I think that's the really important thing about the A level, is being able to be proactive and actually know what you need to work on. And my kind of advice generally for maths is, if you don't like the topic, it's probably the bit you need to do. And you sometimes need the guidance for it. So you need to follow up on it with someone, with a friend, with a teacher, with someone that can talk you through it. And so I think this is really important. Oh, that's lovely. And that's lovely to hear. But yeah, really well done today, everyone. And as I said, the courses, there is a discount on the course. So if you've enjoyed the session today and you think some of these resources might be useful, please do use that code. I'll reshare the PowerPoint so you can kind of get that back up. But thank you again to everyone for working through that content today. We will have web classes coming up again. They're running always on the Sundays, so look out for them. But the Snap Revise courses, as I said, you've got the bite-sized teaching videos, you've got smart quizzes. The revision guides are just really perfectly designed. They're really lovely and easy to use. The exam walkthrough videos. really brilliant for knowing exactly how to approach exams. And I think that skill is excellent. Thanks, guys. That's something that people really struggle with, because especially over the last couple of years, it's been a real struggle to put yourself in that exam mode and know what to look for and develop exam technique. So this whole platform is designed for that. And there's some brilliant resources on there, and predicted exam packs. So you kind of got exposure to lots of really great resources that will help you prepare for this course. So here's the code, 25% off, back to school 21, 48 hours. So you can use that if you're signing up and you want to try it out. And that would be brilliant. As I said, we are going to have more YouTube sessions, so do look out for them and set a reminder. But thank you so much, guys, for working so well through that. And it's been a pleasure talking you through it. I think that was an important topic to look at and also understand how far that could go across the course as well. But really well done. Keep well, take care, and thanks again for all the questions and answers that have come through. And if you are interested, it'd be lovely to see you at a web class, a drop-in, and again, another one of these sessions as well in the future. But good luck with all your studies this week. Keep well. And yeah, as I said, hopefully speak to you at one of these sessions soon. Thanks again, guys. And yeah, any questions, do ask, and feel free to email in, but check out the website if you're interested. Cool. Take care. Well done again. No worries. Take care. Thanks, Adam. Well done. That's lovely to hear, Hader. And great work today. Brilliant questions and answers as we went through. So thanks very much. Well done, guys. Thanks again.